what we're going to start doing today is talking about sampling, talking about sampling from distributions. In other words, if we don't actually have the value we're interested in for every unit in the target population, which of course we never do, or we rarely do, then we might want to take a sample from that distribution. And what we're going to start talking about now is how we can take advantage of the information in a sample to draw inferences about the population. Now this is the same thing, the same concept we were doing in the non-parametric tests that we previously discussed, in the rank sum or permutation test that we previously discussed. But now we're going to move toward talking about tests that make some assumptions about distributions in order to draw inferences. So let's start with the problem described here. So suppose we're interested in the 2012 presidential election, and we're interested in predicting what the outcome would be, so whether the state would go for one candidate or the other in Oklahoma and also in California. And so suppose that in Oklahoma, you take a poll of 500 people. Suppose you take a poll of 500 people in Oklahoma, and note that in Oklahoma the population is approximately 3.8 million. And we're going to use that set of 500 people who are in our poll to predict which way the state will go in the 2012 election. So now suppose I want to do a poll in California. Note that California has a population of approximately 38 million, so about 10 times as big as Oklahoma. I want to do a poll in California, and I want to produce an equally precise prediction. I want to have just as much precision in my estimate of the proportion of people who are going to vote for, say, the Democrat as opposed to the Republican. I want to have the same precision in Oklahoma and California. In Oklahoma, I took 500 people out of a population of 3.8 million. How many people should I poll in California out of a population of approximately 38 million to get the same precision? Let's think about that problem for a moment.